today's topic is property of determinants. First property, the value of the determinant remains unchanged if its rows and columns are interchanged. Right? Now, if our determinant is A1, A2, A3, B1, B2, B3, C1, C2, C3. Right? Now, we have to change row into column. That is transpose of this determinant. R1 convert into C1, R2 convert into C2 and R3 convert into C3, column 3, right? The value of both the determinants are same. If we solve this determinant and this determinant, we have the same value of both the determinants, right? Next property, if any two rows or columns of a determinant are interchanged, then the sign of the determinant change, right? That is, if we have a determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. If we find the value of this determinant and we have to change two rows, R1 and R3 interchange, right? RC, this one R3, this one R1, R1, R3 interchange, that is C1, C2, C3 and A1, A2, A3, right? Now, if we find the value of this determinant and find the value of this determinant, both the values are same but opposite in sign. Next, third property, if any two rows or columns of a determinant are identical means same, all corresponding elements are same, then the value of the determinant is 0, right? Look at this, A1, A2, A3 and B1, B2, B3 and again A1, A2, A3. R1 and R3 are same. Each element is same. A1, A1, A2, A2, A3, A3. So that without expanding this determinant, we have to write the value of this determinant is 0. Fourth property. If each of the element of a row or a column of a determinant is multiplied by a constant k, then its value gets multiplied by k. That is, we have a determinant this and equal to this, right? Now, we have to find the value of this determinant, which is equal to the value of this determinant, k times of the value of this determinant, right? Now, next, if the sum of all elements of a row or column of a determinant are expressed as the sum of two or more terms, then the determinant can be expressed as the sum of two or more determinant, right? Now, we have a determinant whose R1 elements are sum of two terms, right? Like this, A1 plus lambda, A2 plus lambda 2, A3 plus lambda 3. Now, we have to express this determinant as the form of two determinants separately, sum of two determinants, right? A1, A2, A3, A1, A2, A3, B1, B2, B. Remaining elements are same, C1, C2, C3 plus lambda 1, lambda 2, lambda 3, lambda 1, lambda 2, lambda 3, B1, B2, B3, C1, C2, C3. Next, 6. If each element of any row or column of a determinant, the equivalent tables of the corresponding elements of other row or column and add, then the value of determinant remains the same. That is, the value of the determinant remains same if we applied the operation R1 change Ri plus k times of Rj or Ci tends to Ci plus k times of Cj. Is that clear? Now, the mean of these two properties are, if we have multiply any scalar in any row and then add to the any row, right? This means the multiply with any scalar in any column and add to the any column, right? The value of the determinant remains same. Now, exercise 4.2 question 1. the determinant x a x plus a and y b y plus b z c and z plus c, right? Now we have to find the value of the determinant without expanding, right? Without expanding, we have to use these property. Look at this, c1 and c2. We have to add c1 c2, c1 plus c2 and put c1, x1 plus x plus a, y plus b, z plus c, right? Remaining are same. Now look at this, c1 column first and column 3, both are the same, both are the same. This is the property of determinant. If two rows or two columns of a determinant are same means equal, same, then the value of the determinant is 0. So we get the value of this determinant is 0. If we expand this determinant and also we get the value 0.